Hello friends, thanks for watching my program regularly. But for those who are for the first time on my channel, let me introduce you to my channel. The name of my channel is Jagdish Chaubey and the title is E&E, means entertain and educate. Okay, it has got 5 playlists. The first one is training and metallurgical quality control. Second one is on ISO system, wherein I have dealt with QMS, EMS and IATF. The third one is heat treatment of steel, okay, which is currently going on. The fourth one is short stories written by me in Hindi, Meri Kahaniyan. And the last but most important is Rafi Saab ke Sadabahar Gaane. It's all Muhammad Rafi songs sung by me as a cover song. So that is why the title of my channel is Entertain and Educate, wherein you can entertain yourself with these stories and my cover songs of Muhammad Rafi. And if you want to gain technical knowledge, then you can refer these 3 playlists on metallurgical quality control, training on 5S, time management, then on ISO system and heat treatment of steel. All these 3 technical programs you can refer it. So the choice is yours. You go to my channel by typing Jagdish Chaubey with correct spelling on the search bar of YouTube and then search it. You will get my channel and then again you tap it again and you will find the details about my program, and there you can select whatever program you like depending upon your time and your test. Okay, so let's move to the main program. So this program is on flame hardening. This is a heat treatment series 2 part 7, and this program is a surface hardening treatment that is also known as a flame hardening process. So I'll be dealing with this flame hardening process. Okay, so let's see what it contains. The content is, first of all, the flashback. I have already produced heat treatment series 1, wherein there are 8 parts are there. The details are written here. You can go through this. Okay, and the current series is heat treatment series 2, wherein I have already produced 6 parts, and the 7th part is now I am covering it, that is on flame hardening. Okay, so if you have not seen any of these parts, I request you to go to my channel and see these all these parts. They are wealth of information and with practical knowledge. Okay, so you will gain a lot of things out of this. Okay, so again, so now I move further. Coverage, what it covers. First of all, input of steel. What type of steel is used for this flame hardening process? Here I have already mentioned here medium carbon steel or alloy steels is generally used for flame hardening. If you want to know in the details of this steel used, you can refer IS 3930-1994, that is specification for flame and induction hardening steel. Okay, you can refer this if you want to know in detail. This mentions all the steels which are applicable for flame hardening and induction hardening. Okay, the second one is flame hardening process that I will be describing. Third one is advantage and disadvantages. And the fourth one is applications, and the fourth one is application where this flame hardening process is used. So I'll be covering all this thing in this particular part 7. So let's move further. So first of all, definition of flame hardening. Flame hardening is a surface hardening process in which steel part is rapidly heated above austenitizing temperature with the help of flame, that is, it could be Oxy-Acetylene, torch or other gases, and then quenched by water spray to achieve a desired surface hardness. Means basically in this case you heat the steel part on the surface by help of this flame, which is generally oxy-acetylene plus other gases also. And then you heat it to a austenizing temperature, red hot temperature, and after that you quench simultaneously by water, and you get a very good surface hardness. So whatever surface hardness you desire, you get it, but before that you have to heat it with the help of the oxy-acetylene flame. That is why this process is called flame hardening process. Flame hardening is used to develop high hardness, which results into high surface wear resistance. This also improves bending and torsional strength and fatigue life of the part, and the core of the part remains soft. So the core remains unaffected. In this case, when you are hitting it, it develops a very high hardness, which results into a high surface wear resistance. And this surface resistance, high surface resistance, this improves bending and torsional strength and also fatigue life of the part. But the core of the part is remain unaffected. That remains soft. There is no effect on the core. It is only the surface which is heated up, and then it is quenched. Then it is only the surface which is heated up, and then it is quenched to get a desired surface hardness. In this case, a case depth of 0.8 mm to 6.4 mm can be achieved by properly controlling various process parameters. If you control the various process parameters, which I will be discussing afterwards, you can have a case depth of 0.8 mm to 6.4 mm case depth. Okay. But in case of the steel hardenability is very high, good high alloy steel is used and having high hardenability, then you can get through hardening also up to 75 mm cross section. So this is the beauty of this process, that if you choose a high hardenability steel, you can even through hardened also. But in general, the case depth is maintained between 0.8 to 6.4 mm. Okay. So let's move further. What is this process? The process is that, see, this is a particular job which is to be flame hardened, and this is the area which is the surface area. Now in this case, the part is heated, the surface is heated with the help of this flame. It's a gas chamber is there wherein you have a oxy-acetylene charge or maybe some other gases also, depending upon the use, and then you heat it, and accordingly simultaneously you quench it also. So this is a quenching arrangement, this is a heating arrangement, and then you move from here to here. So as long as you are going to heat it and quench it, the surface becomes very hard. See, this area is a hard surface and this is going through. So this way you can go through the entire surface, and that way you can hard it. So in this particular case, this spray of the water is there here quenching, and then this is the hardened surface which is here. Okay, and this is your, now this particular area, that core area remains soft, it doesn't get hard. Okay, because there is no heating effect. Heating effect is only up to this level. Okay, and the achievable case depth with this is 0.8 to 6.4 millimeter, and in this case the surface hardness which can be achieved is 55 to 60 HRC. Okay, so up to 55 to 60 HRC, depending upon the composition of the steel, whether it is a highly alloyed steel or medium carbon steel, you can achieve a hardness up to 55 to 60 HRC. So this is how this process is there. Now, what are the different methods that I will tell you? So, different methods. First of all, there are 4 methods: stationary or spot method, progressive method, spinning method, and then combination of progressive and spinning. In this case, if this piece is there and very small area is to be hardened, then this stationary or spot process is being used, where this particular spot is heated with the help of this oxy-acetylene charge, and then it is quenched also. So you get a localized surface hardness. Okay, only up to this area you can get it surface hardened. So this is why it is known as, that is why it is known as stationary or spot method. In the progressive method, see, this is the arrangement wherein this is a chamber is there. This is a 4 gas chamber where is oxy-acetylene gas and other things are being used, and this is a chamber for this water quenching arrangement is here, and the part is heated on the surface here, and simultaneously it is quenched also. So as soon the part gets heated up, it is quenched also, and that is why you move from here to here. That is why it is known as a progressive method. In case of a spinning method, like something like this hollow cylinder is there, okay. In this case, this part is rotated like this, spinning is there, and these are the four burners, oxy-acetylene burners are there, wherein this is getting heated up, and these are the pipes through which this is getting quenched. The water is circulated from here and it is quenched also. So it rotates, and at the same time it gets heated up and quenched also. So the entire surface becomes very hard. So that is why it is known as spinning method. And a combination of progressive and spinning in this case, see, this is the arrangement wherein these are the various torches are there, okay, heating arrangement, and then water is circulated here, and there are quenching arrangements also. So in this case, the part is, see, this is the part, this rotates as well as this moves also. So it is both combination of spinning, like this is rotation, at the same time it progressive also. So that is why it is called combination of progressive and spinning method. So these are various four methods which are being used in flame hardening depending upon the requirement of the job, to what extent you want, what type of job is there, what type of surface is to be hardened. Is it a spot, or it is a rotatory job, something like this, or it is a gear. Okay, sometimes gear teeth profiles are also heat treated. Okay, so depending upon your requirement, you choose either of these processes. Okay, so let's move further. Factors which influence flame hardening. What are the factors that are influencing quality of flame hardening? First of all, type of fuel being used. This is the first thing which is most important, is whether you are using oxy-acetylene or oxypropane. Depending upon the situation, you have to select a proper oxy-acetylene or oxypropane gas combination. And the second one is design of the flame head. It is basically to concentrate the heat at the particular point. So this has to be very concentrated effort, so that particular area is heated up. So design is a very important part, so that you heat the specific area. Okay. The third one is duration of heating, to what extent you are heating it. Sometimes if you heat over it, then some scaling may occur. Okay. So you have to avoid this overheating. So that's also there. So you have to avoid overheating during this process. Hardenability of the steel part. This again, in the previous slide I told you, if the steel hardenability is good, you can go up to a great depth of case depth in flame hardening. So this is also important, that what is the hardenability of that part. Depending upon the hardenability of the part or the composition of the part, you can achieve different case depth also, and surface hardness also. Quenching medium, what type of medium is generally used? Generally water is being used, but at times sometime oil is also being used. So that depends on what type of hardness you want. Okay. So depending upon your requirement of surface hardness, you select quenching medium. And the sixth one is method of quenching. By what way you are quenching it, whether you are quenching through integrated system or through individual systems, that depends upon your requirement, okay, and the nature of the job. So all these factors, types of fuels, design of flame head, duration of heating, hardenability, quenching medium, and method of quenching, they are very important. And it's not that it's very simple here. If you want to know in detail about all these things, you have to refer ASM volume 4 on heat treatment. It gives a very detailed discussion about these things. Okay, all these things have various variables or process variables which we have to control during flame hardening. So if you want to know in detail about these things, you have to refer this particular volume 4 of heat treatment of ASM, American Society of Metals. Okay. What are the advantages of this process? First of all, this process is very simple. No complicated instruments and systems are required. Okay. Then a large number of steel parts can be flame hardened. Very large parts which cannot be induction hardened or case carbonized or by other method, they can be flame hardened easily. Okay. Depending upon the area, what area you want. Then it can be done on any shape, whether it is a flat, circular or irregular. This can be done very easily. No decarb, no oxidation, no distortion occurs because this heating is very instant and the heating of the part takes very fast. So there is no chances of getting any oxidation or distortion of the part. Then the fifth one is equipment cost is much less compared to the other process. The total equipment cost is here as compared to the other process very less. Large forgings or castings can be flame hardened. That already I explained here. You can use any large forging or castings also that can be flame hardened. Then faster than carburizing and nitriding as compared to carburizing and nitriding, where it takes 10 to 12 hours, and in case of nitriding even 60 hours is required for a smaller case depth. This process is very fast. Okay. Cheaper steel can be used. You can use even medium carbon steel to achieve a particular hardness as compared to the other processes where you have to use alloy steel for getting a particular surface hardness or case depth. So that's why cheaper steel can be also used. So this is advantages of this process is it's difficult to control temperature because it is all manually controlled. Nowadays things have been changed and things are controlled also, but in general it's difficult to control the temperature. Then difficult to adjust case depth exactly because difficult to control temperature or heating. So sometimes it is difficult to control the case depth exactly what you want. Safety must be taken to avoid any explosion. Okay, that's also you have to take because you are heating and simultaneously quenching it also. And if you are using any oil or something, then you have to take a particular precaution also. Overheating of the surface layer may take place. That's a possibility is there that we have to avoid. And cost per piece is higher than induction hardening. So in case of induction hardening, thousands of pieces can be done within few hours or minutes. Okay, but in this case it takes time. So if you go that way, then the cost per piece is higher as compared to the induction hardening. Okay. So application. What are the application of this flame hardening? First of all, very large parts like large gears, machine ways, drives and rolls, they can be flame hardened. For localized hardening of small areas like valve stems, push rods, cams, these can be also flame hardened wherein you have to have a local area, very small area to be heat treated. Then use of less costly steel in place of high costly alloy steel. It's also cost saving also because you can use a cheaper steel as compared to the high cost alloy steel. And the large forgings or casting that can be also flame hardened. So these are the various applications wherein flame hardening process is being used for getting a good surface hardness along with a good case depth also. Okay. So till now I have covered about flame hardening. What is this flame hardening? How it is done? What are the various four methods by which you can do flame hardening? And what is the system? How this process occurs? Okay, how this part is being heated with the help of the flame, austenitized, and then it is quenched. Okay, so all these things I have covered. Then what are the various factors which influence the quality of the flame hardening? That also I have explained. If you want to go in detail, then you have to refer ASM volume 4 on heat treatment. Okay, for knowing the various details. And then what are the advantages and disadvantages of these processes? And the last one is the application. And the last one is application of this flame hardening process. I ask you to go through heat treatment series 1 as well as heat treatment series 2, wherein I have covered most of the things related to heat treatment with all practical experiences. Okay, and I have tried to solve some of the questions which you must be asking while you are on the job. My request to you is that if you have not gone through series 1 or series 2 various parts, I request you to go through all those parts, see the total part in detail, and I am confident that you will get a lot of information, valuable information, practical information when you go through all this series. So keep watching my programs in future also and support me. If you like these programs, then please like, give your comments And if you are new on my channel, I'll request you to subscribe my channel also, because this process will continue. Okay. So thanks a lot. Thank you. Thank you very much.